Exercise 2 is factorial calculation. Write a C program using a while loop to calculate the factorial of a given positive integer. And then it explains what a factorial is. So I'm going to copy this as before, and we'll go over and put it into Jupyter Hub. So we'll just paste that there. We'll just format it a little bit. And I believe many of you have already seen factorial at some point in your academic career. But just to note, so ChatGPT doesn't seem to want to use the same notation, but often we write the factorial using an exclamation point. So formally, the factorial of n, so we write that as n factorial with the exclamation point, that is the product 1 times 2 times 3 all the way up to n. Okay, so an example of that would be, let's do 3 factorial equals 1 times 2 times 3, which happens to equal 6. Okay, that's 3 factorial. And then 4 factorial equals 1 times 2 times 3 times 4, which happens to actually equal 24. Okay, so maybe you get the idea. And you can see how if you write this program, you could easily verify your answers by using a calculator. And many calculators actually have a factorial button, or you could just compute this yourself from scratch. Another thing I'm going to observe is it says integer in the prompt. So it's clear I'm going to be using integer arithmetic. And I also will observe, as a sort of bizarre aside, that none of us today would like to consider what factorial means if we're not using integers. It does have a meaning. We do not want to think about it. You can go look it up. It's weird. The other thing I'll observe about the prompt is it says the word positive. So to me, what this is telling me is my program isn't going to be tested. Nobody's going to try using my program on anything other than positive integers. So I don't have to test my program on like what happens if I use a negative number. Again, I don't know if I want to think about the factorials of negative numbers, and this exercise is telling me that I don't have to. So if the exercise says positive integer, you don't have to worry about what happens with negative integers or negative real numbers or something like that. Okay, so it seems to think that I should use a value that we use n to characterize a factorial, so I'm going to do that as well. So int n, I'm going to start that at, let's do 4. So 4 factorial equals 24, just as a point of reference. So what I need now is a loop that can multiply 1 times 2 times 3 times 4. And just like in the last exercise, I am going to draw this out from scratch. I'm going to do it the same way we've been doing it this week, which is I'm going to first write some code that I can literally copy and paste. Okay, so I'm going to make my variable that stores the result, I'll call it factorial. And I'll start it off at 1. And at each step, so what I want is I've got, 1 times 2 times 3 times 4. I'm going to start with just having a 1. That would be this. And then I'm going to go through and multiply it by first 2, and then 3, and then 4. So I guess I'm going to need something that counts 2, 3, 4. I'm going to need a variable that stores integers counting off 2, 3, 4, 5, 6, 7, 8, so it counts up by 1 at each step. I guess I'll call that variable, because it's doing counting, I'll call it counter. The counter is going to start off at, well, I guess we'll start it at 2. Okay, so the counter starts at 2, and then at each step, what am I going to do? I'm going to multiply the current factorial, so factorial equals factorial times counter. And here's my logic. So I start the factorial off at 1, and then I want the factorial to be 1 times 2. So this is the new factorial value. Then I do 1 times 2 times 3. I mean, I take this factorial and it's just the 1 times 2, and I fold in a 3 here. So I'm multiplying by one extra thing at each step. All right, so factorial equals factorial times counter, and I want to increment the counter. So counter equals counter plus 1. So as of the first step on line 19, factorial is 1, counter is 2. As of line 22, counter should be 3 by now, and factorial should be 1 times 2. And if you don't buy that, try tracing it. Or actually, first try doing this exercise yourself, and then if you don't believe my solution, try tracing the code yourself. Okay, so that means that right now, I'm going to even make a note of that. So as of now, factorial should equal 1 times 2, and counter should equal 3. Okay, so I'll copy and paste this code. We'll do one more round of this. And then I'll remind myself what I want. which is the factorial should now equal 1 times 2 times 3, because I took, at this step here, I took the old factorial value, 1 times 2, that would be this, and I multiplied it by the current counter value, which is 3. And the counter here should equal 4. Okay, now before I go further, let's print that out. I'm going to print out everything I know. At the end of this, I only want to print out the factorial. But for now, for debugging, just for testing things out, I want to print out everything I know. Factorial is this, and counter is that. So I'll print that out, factorial and counter. This is, whoops, this is my old exercise 1. We're going to change this for exercise 2. And this is a reasonable warning to get. We'll ignore it for now because I'm not ready to use that variable yet. And we can see the factorial is equal to 6, which is exactly what I wrote in my comment, and counter equals 4. The reason I wrote this comment was so that when I ran the program, I'd be able to write down what I think should happen. If I think the program has these values and it ends up that it does, then that's a good sign that I am keeping track of what's going on. Okay, so I'm going to try doing one more iteration of this to make sure I'm absolutely confident that I have this in the right order. So now the factorial should be, well, previously it was 1 times 2 times 3. I'm going to multiply it by the current counter value of 4, which means it should now be 1 times 2 times 3 times 4, which is going to be equal to 24. And the counter should now equal 5. Okay, so print that out. I'm expecting this to print factorial is 24, counter is 5. Okay, and it does. That's a good sign that I have the right logic. Now the question is, how do I make a loop? So I need those 3 ingredients of my loop. In the exercise, it says I have no choice but to use a while loop. Okay, so I think I know my first ingredient, my initialization. That's this. Okay, so because it's a while loop, I just leave that there. And now I need a continuation condition. Okay, so here's my observation. When I want to compute 4 factorial, the value of my factorial variable equals 24, which is equal to 4 factorial, at the same time that counter gets incremented to 5. And so I'm going to go out on a limb here and say that maybe what I want to do is count up to 4. So I say counter is less than or equal to 4. And here's where I got that idea from. When counter equals 5, then the loop is going to end. And notice how, when counter equals 5, my factorial is finished. So I guess it makes sense for the loop to end there. Okay, so there's my second ingredient, my continuation condition. And now the question is, what do I put inside my loop? And of course, where is that third ingredient? Well, the thing I was copying and pasting was these 2 lines. So notice how I've copied and pasted it several times. That's a sign that maybe this is what goes inside the loop. Okay, and then we'll indent that. And this, I think, is my incrementation. This is just an operation that I happen to be doing during my loop. But counter equals counter plus 1, I mean, that's a pretty classic incrementation condition, or incrementation statement. I'm going to go wipe out all this other stuff that I copied and pasted. And this printf isn't what I want in the end, but I'll leave it in for now just to remind myself what I have, to make sure I'm still on the right track. I should still have, so it's still saying n isn't being used because I'm just saying counter is less than or equal to 4. But I'll get there. Okay, so factorial is still 24 and counter is still equal to 5. Okay, so now let's change this to use counter goes up to n, because I want to compute n factorial. Now n is equal to 4, so I should still get factorial is 24, counter is 5. Let's see what happens if I change the value of n. Okay, so 4 factorial is 24. What's 5 factorial? So 1 times 2 times 3 times 4 times 5. Okay, well actually, I know that this is 24 because this is 4 factorial. So what is 24 times 5? And this is something you probably do need a calculator for. I happen to know the answer, but only because I've done so many factorial exercises in my life. It turns out it's 120. Okay, so 5 factorial equals 120. Okay, and we'll clear that. We'll try running this, and we hope that it now says that the counter is equal to 6 and factorial equals 120. And sure enough, it does. Okay, so now I think the exercise is done up to the testing I need to do, but I need to print out the data. I need to print out my output in a way that makes sense. So I want to write something like n factorial is, and then I print out the factorial itself. And then I'll print out n, and I'll print out factorial. Okay, so we'll try that out. There we go. 5 factorial is 120. Okay, so what do I do for testing here? Okay, well first, let's try it on 3. We know that 3 factorial is equal to 6. Looks good. I want to try it on a bunch of inputs that are valid inputs. It says any given positive integer. So positive means it's greater than 0. So I'm not going to worry about 0 factorial. I guess I should worry about 1 factorial. Okay, so wait, what is 1 factorial? Well, 1 factorial is just 1 times nothing. So it's just 1. Okay, so let's try 1 factorial. So I'll set n to be 1. Okay, 1 factorial is 1. No surprises there. Let's try 2 factorial. That should be equal to 2. That also looks good. Let's try, we already tried 3 and 4 factorial and 5 factorial. I think things are looking good. Let's try at least one other one. We'll try 10 factorial. And it says 10 factorial is that number. Now, again, I've done enough factorial calculations in my life that does look more or less like what I expect, but I can't guarantee it. So over here on my other computer, I'm going to quickly do a calculation. I'm just going to use a calculator over here to check that 10 factorial is indeed equal to 3628800. So that's a decent amount of testing. One thing I'll observe that's neat about this exercise is because these numbers, as you can see, are getting very large very quickly, if you were to set n to be too big, and this, you don't need it to be that much bigger, if you set n to, let's just try, I don't know, 20 maybe? If you set n to be too big, you're going to get strange behavior. So this is obviously not supposed to be. 1 times 2 times 3 all the way up to 20 will not be a negative number. Does that mean my code is broken? The answer, it turns out, is actually no. What's happening is the value of 20 factorial is so big that it doesn't fit inside of an int. So we already know that an int variable has a range. The values you can represent are between more or less negative 2 billion up to positive 2 billion. And it turns out that 20 factorial, I'm just going to check on my other computer, 20 factorial is, oh wow, yeah, 20 factorial is way bigger than 2 billion. I don't even want to count the number of digits. It's a decent number of digits. So as a result, if you use an int, it's not going to store. I don't know, as maybe an extra credit exercise, let's see if we can adapt the program to work to display 20 factorial. So we know already that int has a limited range, negative 2 billion to positive 2 billion, give or take. And we know that if we need a larger range, we have to use something else. We could try using double, but it does say integer. I'd rather keep everything in the integer realm here. So we could also try using an integer type with a larger range. And there's one type with a very large range, so long int. And if we're going to work with long int, we should change all of our variables that are involved to long int. We don't actually have to, but that's way easier than trying to figure out which ones should change and which ones shouldn't. Another thing we should do, and this is something you wouldn't be tested on, but just since we're here and doing this exercise, when you want to print a long int, you have to use not %d, but %LLD. Just to remind it that this is a long number, not just a regular number. So we'll try that out. And here we get this value. Notice how many digits that has. So 2 billion, let's see, this is definitely, okay, there's 6 digits, there's 9 digits. Okay, so this number here already, just this number beginning with an 8, that's 8 billion. So you can see the number we have is way bigger than 2 billion. And it turns out, based on the calculation I did over my other computer, it turns out that this actually is 20 factorial. So by using long int, I was able to get enough range to store 20 factorial. But that said, factorials grow so quickly that if I pick a big enough value of n, I could also break even my long ints. You can see 40 factorial, okay, it's not supposed to be negative. So you can see that factorials get so big that even long int isn't going to help me after a while. Okay, that's enough. That's a bit of an aside. We don't need to worry about long int this week, but just in case we were curious, there it is. And so I think we are now ready to move on to exercise number 3.